All right, this starts day 6 notes on exponential decay. So yesterday we learned all about growth. Today is going to be about these decreasing exponential functions, and we're going to see how that makes sense in the real world in a couple minutes. But to start, let's look at an example where we are actually given a function. Let's read example 1. A fully inflated snow tube loses 5.8% of its air every day. The snow tube originally contains 3,000 cubic inches of air when it's first inflated. The equation, and as soon as I see that I'm given an equation, I'm going to highlight it, models the air loss, so I'm going to underline that because that's what this entire equation is about, after X days. So we really have to make sure we're comfortable with defining variables, because even if it doesn't ask me to define variables, I expect you to do that. So I'm told that X equals number of days, and my Y, or f of X, however you choose to write it, is air loss, because that's what this entire situation is talking about. I'm actually going to say total air loss to be even more specific, because Y is always about a total of some kind. Here, air is measured in cubic inches. We saw that with the deflating pool question a couple days ago. So I have my variables defined, and I actually have a model, so I don't have to build it. I just have to answer this question: estimate the amount of air in the raft after 7 days. X is days, so this is a value for X. Let's use our model. So we're going to calculate A of 7 equals 3,000 times 0.942, and I said A of 7, so wherever we see X, we are substituting in 7, so I put a 7 as the exponent. If you haven't gotten your calculator out yet, please do that now, because this is purely a calculator question. So in your calculators, in green, I'm going to put what you need to type into your calculators. 3,000 parenthesis 0.942 caret 7. On a phone, if anybody's using a phone, you're going to have to do this a little differently. You are going to type in 0.942, and then you have a button on your phone that looks like X to the Y. I'm going to move that over. Something like that. 0, so again, 0, my phone people in purple off to the side, 0.942, and then look for some kind of button, X to the Y, and then hit 7. That's the phone's version of a caret. Don't clear out that answer. As whatever number you get, then hit times 3,000. So this is on a phone. In both cases, we should be getting, as an answer, 1,974.593 when we round to 3 decimal places, cubic inches. And a sentence is always really nice. So to know how to write the sentence, you can actually take your question. You were told, estimate the amount of air in the raft after 7 days. So we will write, after 7 days, the raft will have approximately this answer, 1,974.593 cubic inches, inches cubed, of air left. If you need to pause it to finish writing your sentence, do that. That's a big drop. You started off with 3,000 cubic inches of air, and just after a week, you're down to 1,974. Our follow-up question says, according to park safety guidelines, the tube must have at least 2,000 cubic inches of air. Will it be safe to use this tube on the 7th day? The answer is definitely no. There's not enough air. If you wanted to quantify that with your answers, you got 1,974. That is definitely less than the allowed 2,000 cubic inches minimum. So on a quiz or a test, if you were asked to explain, don't just say no, make sure you actually give a reason. Just like we started off with a situation like this, and then we broke down where did it come from in the growth notes, we're going to do the exact same thing here with decay. So it says, where did the equation come from? Look at each piece of information. What do you notice? So if you didn't actually highlight that yet, please highlight here, and let's highlight this one, because that's what we're going to analyze right now. Where did this come from? Well, my first thought, when I come back up here and I look at the given information, just like with growth, we have an initial value. I'm told that it originally contained 3,000 cubic inches. Just like with growth, that is my initial value. So let's label that initial value. That's my A. So no difference there. So label that initial value A, and let's come down here. A is initial value. So this piece is accounted for. Now the question is, where did this come from? Interesting. Let's see if we can figure that out. So when I come back up here and I look, I don't see anything that looks like 0.942, but what I do see is that I'm told that the snow tube loses 5.8% of its air. This is still called a growth rate. I know it's technically saying it's losing it, but there's really nothing called a decay rate. So this is still called a growth rate, even though it's decreasing. The fact that I see that keyword loses tells me right away this is decay. So over here, off to the side, let's work with that value. R equals, I'm going to count for A first. A was 3,000, just so we don't lose the fact that we identified that first. R is 5.8%. My question to you is, can I keep this as a percent? Answer is no. We need to get this in decimal form. So you have two options. You can move the decimal place twice, 1, 2, and get 0.058. That action of moving the decimal place is the same thing as 5.8 divided by 100. Do that in your calculator. Do 5.8 divided by 100, and we'll get 0.058. And again, where did that come from? I was told in my real world question or problem that the snow tube is losing air at a rate of 5.8%. So two options. You can either move the decimal place twice to the left and get 0.058 or divide by 100. Either way, we have to have the decimal form. But the question still stands. Where did this number come from? What is the connection between 0.942 and 0.058? That tube started off with 100% of its air. 100% as a decimal, so to speak, 100% divided by 100, that equals 1. So this 1 represents 100%. It's losing air minus losing air at a rate of 0.058. So right now in your calculators, please do 1 minus 0.058 and see what you get. In your calculators right now, 1 minus 0.058. And when we do that, we get our 0.942. So don't just listen to me say that. Make sure you really actually try that in your calculator to see that it comes out to be 0.942. So this is 1 minus the growth rate. That action of 1 minus the growth rate gets us the growth factor. So R is my growth rate. And I want you to specify in decimal form. It has to be as a decimal. You cannot just use the percent. With decay, it's now 1 minus R, as opposed to growth that was 1 plus. T is still time. And this should say F of T. F of T is still a total amount, the output. What's the total? Total amount of air, total amount of money, whatever it may be. So now that we have an understanding of where this model comes from, we still have a note, just like on growth. And the note sounds a lot alike, just like yesterday. Before you use the model, subtract 1 minus R first inside parentheses to get one number. Before you use the model, subtract 1 minus R first inside parentheses to get one number. What I mean by that is here, if I was building this model, my first step would say 1 minus 0.058. I have to do that subtraction to get one number inside parentheses. The best way to get good at this is to practice. So let's look at our first example. We try. Mr. Wonderful from Shark Tank agreed to invest $50,000 into your business, but you're doing an evaluation of your business and realize that his investment is losing its value at a rate of 2.7% each year. What will his investment be worth in 5 years? So if anybody's ever seen Shark Tank, it's a really cool show where people, they're entrepreneurs, they started their own business, they've made their own product, and they approach these investors. He's one of 4 or 5 on the show, and these guys are millionaires. It's not made up, it's live. They make a decision if they'll invest in your business or not. And it's really cool, like, to hear how these numbers work. They're very specific with their profit, what's their cost. It's a really cool show. If you've never seen it, you can type in this YouTube video into your phone and watch a quick little clip on it. So Mr. Wonderful has said yes to giving you your requested $50,000, but now over time you're realizing, oh no, that money is losing value. So let's see what happens here. Our very first step, as always, will be to define our variables. So I see a mention of years. I don't see any kind of 0 year. So we're just going to say x is number of years. We have to define variables. I can't stress that enough. X is number of years. Then to know what f of x is going to represent, I have to think to myself, what total is being discussed here? Well, this entire question is about money, the investment. So value of investment in dollars. Straight back to prior knowledge, your IV, your DV. Time is always X, and then what total is being discussed. You have to reason on that. You could also see each year as a keyword, per, each, or every, each year. All right, we've got our variables. Next, we have to get A and R. Please get in a good habit of actually saying A equals, R equals off to the side. That's how we're going to build our model. So I go and I look for my initial value. So the question is, what was initially invested? $50,000. So circle that and label it A. So A is 50,000. Next, I'm looking for the rate. This entire set of notes is under the title Decay. So you know that this is going to be decay. I just want to mention that when we get into mixed practice, you have to know that based on that word losing, that this will be a decay question. There's my R. R is 2.7%. You decide how you're going to turn that percent into a decimal. You're either going to move the decimal place twice to the left or divide by 100. Totally your choice. Do one of those things and we'll see what you get. Twice to the left would make this 0.027, or if you don't like that, that's okay. In your calculator, do 2.7 divided by 100, and again, you'll get 0.027. We have to get the decimal form. So we've got A and we've got R. Very exciting. How do we build our model? At the top, just like with every other setup we've done, let's put the general model. So the general model for decay is f of x equals A times, and I'd ask you, what goes on the inside? 1 minus R raised to the x. You have to memorize this. Yep, this is only when it's decay. If this was growth, it would be 1 plus. Decay is 1 minus, where A is my initial value. So see how I write this in red? If you have a pen nearby, trace over A with your pen and write initial value so it stands out. And then R is my growth rate. What I just put in red are the only two values you need to get to build the model, and we did. Here's A, here's R. So what I'm about to write, it's not coming out of thin air. I'm literally following this model exactly. And what I mean by that is I'm going to write f of x equals A, 50,000, open parenthesis, and I say, okay, what does my model say? My model says 1 minus R. So I'm going to write 1 minus R. I've already done my little side work here, and I know that as a decimal, it's 0.027 to the x. To know how to write this, I literally followed this exactly as it says. So taking a second to put this at the top of your paper really helps. Now comes in that little note we said. We're not ready to use the model because we actually have to do this subtraction first. So in your calculators right now, please do 1 minus 0.027. 1 minus 0.027. So we get f of x equals 50,000. And then when we do that subtraction, we look back at our calculator and we see that we get 0.973 to the x. That's our model. Put it in a box. Now that we have our model, we're ready to actually use it to answer this question: what will his investment be worth in 5 years? So years is a value for X. Let's do f of 5. So off to the side, f of 5. And now this is purely a calculator exercise. Wherever you see X, you're plugging in 5. So this is going to be f of 5 equals 50,000, parenthesis, 0.973 raised to the 5th power. So take a second, use your calculator, let's figure that out. People using a phone, make sure you do 0.973 raised to the 5th first, then times 50,000. But on a quiz or a test, phones are not allowed. So please make sure that if you do not have a calculator yet, you get one. In a calculator, you do 50,000, parenthesis, 0.973, caret 5. And as an answer, we get $43,604.79. So in 5 years, the investment will be worth $43,604.79. All that was is just saying, what does this actually mean? This process does not change. So let's look at our next two. These are technically labeled independent practice, but I do plan on doing a piece of each of them with you. And then when I ask you to pause and finish, please do that. Please pause and finish on your own. Let's read number 1. Last year, an estimated 4,324,000 people in this country are illiterate. Illiterate means that they can't read. With new incentives and funding, the country is hoping to cut that number by 11% every 3 years. How many people do you predict will be illiterate in 2035? First step is always to define variables. X equals, f of x equals. Now here, I see that years are being mentioned, but I don't have a 0 year. This is where reading for information really comes into play. We're told last year. So this year is 2017, which is when this is being recorded, which makes last year 2016. So X will be number of years since 2016. There is no math involved in knowing that. That is purely a reading for information and realizing it's telling me that last year, this was my initial value. Last year was 2016. To know what my total is, you have to ask yourself, what is this entire question talking about? Well, this entire question is talking about the number of people who can't read. So number of people, or number of illiterate people. There's many ways to write this. However you choose to write it is fine. Illiterate people. The total number of people who still can't read. Mentally, I want to ask you what comes next. What 2 values do I have to identify? When I look at what I did up here, the very next thing I did was I found A and I found R. So let's do the exact same thing. A equals, R equals. Go find A. Circle it and label it A. I hope you circled 4,324,000. That's A. Because in my initial year, 2016, that's how many people couldn't read. So 4,324,000. Now I'm looking for R. What is my growth rate, or quote unquote decay rate? I'm told, well, you circle it, and then we'll see if we circle the same thing. They're trying to cut that number or decrease that number by 11% every 3 years. Also include the 3 years in your circle. That's going to matter. We need a rate that is per 1 year, not per 3 years. So this is a little piece of new learning. To figure out the percent per 1 year, we actually have to divide. So we have to do 11% divided by 3. So right now, please do 11 divided by 3 in your calculators. Sure. That gets us and it says 0.6666 repeating. So let's round that to 3.667%. So now I have a percent per 1 year, which is what I needed. But it's still a percent. I need a decimal. So you make a decision. You're either going to move your decimal place twice or divide. Either way, you're going to get the same answer. So if I move it twice, I get 0.03667. If I do 3.667 divided by 100, I still get 0.03667. That's the decimal I need. So big picture, the point of this question being in your notes is to help you to realize that sometimes you might have to do a little work. If you're given a percent per 3 years or 5 weeks or 10 years, whatever it may be, it has to be per 1. And to do that, you need to divide. We've got A, we've got R. We now need to build our model. I'm going to follow this exactly. So look at the top of your page. That's exactly what we're going to write. So you try first. Right now, try on your own, filling in A and filling in R, and we'll see if what we write matches. When you're ready, let's see if we match. Question: are we ready to use the model as it is? The answer is no, because we have to subtract first. So go ahead and do your subtraction. 1 minus 0.03667. That will get our number on the inside. Do the subtraction and keep it on your calculator for a second, because we still have to rewrite the starting of this. F of x equals 4,324,000. And when we do 1 minus that rate, we get, inside parentheses, 0.96, and then 33333. So we'll just round that to just a single 3. So we have 3 decimal places to the x. That's my model. Let's put it in a box. We're now ready to use this model to answer this follow-up question about how many people do you predict to be illiterate in 2035. My 0 year is 2016. So off to the side, we need to do 2035 minus 2016 to figure out how many years that is. So go ahead and do that subtraction in your calculator. Do 2035 minus 2016, and what do you get? 2035 minus 2016, we get 19. That's what I'm plugging in. I'm going to write at a kind of an angle so I can fit mine, just because the marker is a little chunky. So f of 19 equals, and I'm just going to plug it in and do the calculator. So 4,324,000, parenthesis, 0.963 raised to the 19. And let's see what you get. So take a second. What do you get as an answer? Write it down, and if you can, give it a meaning, please. What does it mean? So I'm just going to write the number, and then I'll see what it is. 2,112,443.688. To know where I put my commas, I start at the decimal, and then I go left every 1, 2, 3, comma. 1, 2, 3, comma. So the sentence is, in 2035, in the year 2035, 2,112,443 people will be illiterate. Put this in a box to make it stand out. And you're done with that question. So just because we're working with big numbers, don't let it be intimidating. That's what a calculator's for. Let the calculator do all the heavy lifting. Let's look at our last notes example, number 2. The house down the street has termites in the porch. If you don't know what termites look like, they're these really gross looking bugs. The exterminator estimated that there are about 800,000 termites eating at the porch. And this is what they do to wood. This used to be a solid block of wood, and notice it's been all eaten away. So when people go to buy a house, that is one of the most important things that a home inspector will look for, is there termite damage, because there's no fixing it. Like, if they eat enough of it away, it can literally collapse the floor in the house, because they literally eat away at the entire support structure of the house. And it's very expensive to get rid of them. So the exterminator said that the treatment he put on the wood would kill 40% of the termites every day. How many termites will be eating at the porch in ... And we have 2 questions, 3 days and then 2 weeks. So as always, our first step is to define variables. Please look for per, each, or every, and you define variables on your own. What's x? What's f of x? Give it a shot. Define your variables and we'll compare. X is going to be days. It tells me every day, each day. So X is number of days. F of X will be what total? What is this entire question talking about? Termites. So number of termites left. Ask yourself, once you've defined your variables, what's the next step? A and R. So A equals, R equals. Let's find those 2 pieces of information. What's A? Look for it. What's the initial number of termites in this porch? Circle it, label it. A is 800,000. It's a lot of bugs. 800,000. Again, this entire set of notes is technically decay, but I just want to mention, when you have mixed practice, which starts tomorrow, you want to be able to recognize that to kill something means that the number is decreasing 40% each day. So I can just straight up take 40%. I don't have to worry about any division because I'm told per day, per 1 day. If this said something like per 7 days, you would need to do this divided by 7 like we did up there. But we don't have to do that because it's every day. As a decimal, make a decision. Decide. If you're going to move your decimal point, recognize that the decimal is right there. So moving it twice makes that 0.40, or do 40 divided by 100 and you still get 0.40. I've got A, I've got R. What comes next? What do I do next? Got to set up the model. So mentally, have it in your head, or look at the top. Look at what you wrote at the top. That's exactly what we're going to write. So try on your own to write the model, and then we'll compare. That's what I got. Do we match? Remember to do your subtraction to get your final model. All that's left is for us to actually answer the question, how many are left after 3 days? So let's figure that out. Let's find f of 3. And again, you do that on your own, and we'll compare answers. So in my calculator, I type in 800,000, parenthesis, 0.6, close the parenthesis, caret 3, and I got 172,800. As a sentence, after 3 days, there will be 172,800 termites left in the porch. Last part. This should say, I'm not sure why it says C, it should be B. That was A, this is B. 2 weeks. So we know how many termites we left after 3 days. Now we're asked 2 weeks. X is defined as days. So we actually have to realize that we're really being asked 14 days. So on your own, we're using the same exact model and just finding out after 14 days. So go ahead and press pause here. You do your work, I will do mine. When you press play, all of my work and my sentence will appear, and we'll check answers. So if you didn't press pause right now. Press the space bar. All right, so this is what I got as my answer, 626.913. You can't have 0.9 of a termite. So in terms of the real world answer, after 2 weeks, there will be 626 termites left. A drastic reduction. You went from 800,000, and by the end of the second week, you're down to just 626. Now, to take care of a termite problem, you have to have none left. So it's still an issue. The exterminator will keep coming back until there's none. That rounds out the notes. So tomorrow in class, you will be working on the day 6 homework practice. Any questions on the notes, please send me a remind. Have a great day.